Okay, you had a worksheet dealing with logarithms, working through the basic idea of what logarithms will do for you. Once again, the hope is as you go through this, and as you went through yesterday and worked through yesterday, the idea of logarithms is not quite the mystery that it maybe has been before we started in there. Because sometimes logarithms, things that we don't do on a daily basis, tend to be a little bit more difficult and work through the problems as you work through the logarithms. They tend to be a little bit more difficult just because we don't experience logarithms on a daily basis. But as you work through these, hopefully it eases some of your anxiety towards logarithms and working through the idea of logarithms. If you continue to work with the idea that, and remember the idea, if you have a log, you have to have a base. You're going to have a value whenever you find the solution to any type of logarithm is going to be an exponent. So we have a base, we have an exponent, and we have a value that we will come up with. And being able to transfer between these two things is a key idea because I think we feel a lot more comfortable working with the idea of exponents than we do logarithms because we're not used to logarithms. So putting it into an exponential form will hopefully once again ease the anxieties of working through the idea of logarithms. Is there anything that you need me to go through in regards to the problems on the worksheet? Solutions were provided for you. Those are things that you still need me to go through. All right, well, please once again keep up with the material that we're dealing with here. Because this will be the last of the material that we go through with respect to logarithms. Monday will be an in-class assignment and another worksheet that combines the idea of logarithms and what we've been working on. Tuesday will be a review day. Wednesday will be a chapter test. I will also hand out the review sheet for the final on Wednesday. And the hope is to get the final done before we go on break. So we don't have to try to remember through the idea of break all the information. So I'm looking at Friday, Monday, or even Monday, Tuesday when we come back, or before break to be able to get the final. There'll be a 2-day final in there. Okay, just ideas that we've talked about already. When finding a logarithm of a value, the solution is the exponent to the base of the logarithm. Base exponent is equal to value. Log with a base as a value is equal to an exponent. We deal with a common log, that's log base 10. That is your calculator log. The log that you see on your calculator is your common log or your log base 10. We also have the natural log, which is log base E, which is your ln button on your calculator. That is your natural log. Now, properties of logarithms. When I have log base b of two things being multiplied together. Well, think about when you're dealing with logarithms, logarithms are exponents. If we have a like basis and we're multiplying together, what do we have to do with the exponents to the two things that we are multiplying together? If I have x to the third times x to the fifth power, I have a like basis, and I'm multiplying these two things together. What do we have to do with the exponents to solve this problem, to simplify this? There, add them. We have to add them. This is x to the 3 plus 5 power, which is x to the 8th power. We add the exponents. Well, when I have a log, whenever I'm dealing with logarithms, the solution to logarithms are exponents. So when I have two things being multiplied together here, that is the same idea that we had to deal with here. we have to add those exponents. So if I have a log base b of a times x, this is log base b of a plus a log base b of x. So we have to add their individual logarithms. I can't distribute and say log base b of a times log base b of x. I need to add them together. Sort of like the idea of sine and cosine of the angle of addition. We can't just distribute over the parentheses. When I have division of two things, well, when I'm dividing on like bases, I have to subtract the exponents. So I have log base b of a minus a log base b of x. Whenever we take the log, does not matter what the base is of the value of 1. My solution is going to be a value of 0. Because b to the 0th power is 1. 2 to the 0th is 1. 5 to the 0th is 1. 7 to the 0th is 1. 10 to the 0th is 1. Anything to the 0th power is going to give me a value of 1. So once again, whenever I take a logarithm, the answer to a logarithm problem is going to be an exponent to the base. Well, my exponent is a value of 0. My base is a value of b. b to the 0th power is a value of 1. If these two things are the same, does not matter if I have log base 2 of 2, log base 5 of 5, log base 10 of 10. Does not matter. If my bases and my value are the same, my answer is going to be a value of 1. And you can ask yourself, what exponent do I need to take b to get b? Well, let's just be to the 1th power. Logarithms will also be undoable processes. How we solve equations. If I have log base b of b to the x power, this will just give me x. Or if I have an exponent and my bases are the same, if I take a look, if I have a base here and a base here that are the same, they will cancel each other out. So if I have a base b and have an exponent of log base b of x, they will cancel each other out. Now, probably the most important property for us, and the usable property for us for logarithms, is the next one. Log base b of a to the x power. The problem we run into is when our variable that we're trying to solve is in the exponent. If it's in the exponent, if I have x squared, I can take the square root to get rid of my square. But if I have 2 to the x, I can't take the x root to get rid of the exponent of x. Even though your calculator will give you an x root, it's going to ask you what root are you wanting to deal with. So this one here is probably the most important one that we deal with because it allows us to solve equations. We have log base b of a to the x. This is equal to x times the log base b of a. This exponent can get moved out front and multiplied by the logarithm. What this allows us to do is this allows us to be able to solve for a variable x that's in an exponent. The logarithm allows us to pull out the variable of the exponent in the exponent. So it's one of your probably most important properties of logarithms. We'll utilize this to solve equations. Also, if a is equal to x, I can take the log of the same base to both sides and I still will maintain equality. We've talked about whatever you do to one side, you do to the other. They are operations that allow us to be able to maintain equality. If I take the square root of both sides, I maintain equality. If I square root both sides of the equation, I maintain equality. I take the inverse sine of both sides, I maintain equality. I take the log, same base of both sides, I maintain equality. So if we use our properties of logarithms, writing it as a single logarithm, I have three logs that are being multiplied or being added together. Basically what we have is we have this here. And I want to write it as one single log. Well, if these logs are being added together, I can write this as one single log of all the things being multiplied together. 5 times 4 times 7. All we're doing is we're taking this process and putting it in reverse. If I have two logs being added together with the same base, I can write it as one log of both of them being multiplied together. So we have a log of 140. I have 2 log of 5 plus 3 log of 2. I want to write it as one single logarithm. Now I got logarithms that are being added, but I still have coefficients there to each one of these. So I have multiplication by these coefficients. Utilizing this property in reverse, when I have a coefficient to log, I can write it as the exponent of my value. So these values that are coefficients can be taken back up to my exponents. So we have the log of 5 squared plus the log of 2 cubed. Which now I can combine together through multiplication. Log of 5 squared, or 25, times 8. Which gives me the log of 200. Next one, my exponent of 2 can go up to here, or my coefficient of 2 can go to my exponent. But I have a subtraction there to log of 5. Well, when I'm dealing with subtraction, with my properties up top, what we're dealing with is we're talking about division. We have multiplication through addition with these first two. This will give us multiplication, but this negative sign here will give us division. So if I go from left to right, I'm multiplying these two together, and then subtracting this one off, I'm dividing by my third value. So we have the log on top, we have 4 times 9. 3 squared is 9. And log of 5, that drops the 5 down to the bottom. So we have 36 fifths. I don't think the copy machine is working. Brooke? our exponents, our coefficients will go up to our exponents again. Okay, write yourself an expression for the last one here. Now what we're subtracting off is that entire quantity, but inside that quantity we have addition inside the quantity. So the addition tells us we have multiplication, but when I subtract that quantity, that's going to give us division. We have one single log. Check your answer somewhere around. Amber, what do you get here? A log of what?
X squared. Y to the fifth power times E.
Okay, where we're going to put that at? On the bottom. So we have x to the fifth divided by y to the, x to the second divided by y to the fifth z, because we're subtracting off that entire quantity. Given the ln, the natural log of x is equal to 7, the natural log of y is 10. I want to calculate the natural log of x times y. Now the ln of x is 7. The ln of y is 10. I have x and y connected inside the logarithms. What we need to use is our properties to be able to split these two out and give them their own separate logarithms. So if I have the log of ln of x times y, using our properties from up above, how can I split these two apart? John, how can we split these apart?
Log of 7 and log of 10.
No, I just wanted to split apart the ln of x times y. How can I split it apart? Ln of x plus the ln of y. Okay, I'm just using the property from up above. Be patient with this. Now the ln of x is given to us as a value of 7. The ln of y is giving us the value of 10. So we have 7 plus 10, or 17. Split these two apart. Split these two apart, ln of y squared x, give them their own separate logarithms. Then we have an exponent to our x. What can we do with the exponent to the x? And then make your substitutions for the ln of x and ln of y. Todd, breaking these apart, what do they break apart into? ln of y squared plus the ln of x. Now we have the y squared. We have an exponent of 2. So the y. What does our properties allow us to do with that 2? Put it in front. So we have 2 times the ln of y plus the ln of x. Now we can make our substitutions. We have 2 times the ln of y, which is a value of 10, plus the ln of x, which is a value of 7. So we have 2 times 10, which is 20, plus 7, or 27. Once again, quick and easy ACT questions. Okay? Quick ACT questions if you know properties. Okay, go to the next one. ln of x squared divided by y cubed. First, split them apart into 2 separate logarithms using the properties. We have division. Then deal with your exponents. What can you do with your exponent? And then make your substitutions. Callie, breaking these apart? Well, how can we break these apart? Okay, so she brought the exponent out front already. 2 ln of x minus the 3 ln of y. We can have ln of x squared minus the ln of y cubed. The 2 will come out. The 3 will come out. So we have 2 times ln of x, which is 7, minus 3 times the ln of y, which is 10. So we have 2 times 7 minus 3 times 10. Brianna, what do you come up with? Negative 16. To the x is equal to 8. And we can use our noggin on that one and solve that problem. We get a value of what then? 3? 3 to the x is equal to 30. ACT question. 3 to the x equals 30. Solve for x. Option A will be 10. Option A will be 10. 3 to the 10th power is equal to 30. Well, if I had x cubed is equal to 30, I could take the cube root of both sides and be able to solve the problem. But once again, your calculator will not allow us to do an x root and be able to come down to a solution to solve for the root. So how do we solve something like this? Well, I could try to break 30 out into a factor of 3, okay, but I can't say 3 to any power is equal to 30. But what we do have, though, is we have our idea of logarithms. Once again, one of the most important properties of logarithms is the property that allows us to take the exponent out of the exponent and move it to a coefficient. And if two things are equal, then their logarithms will be equal. If two values are equal, their logarithms will be equal. So if I take the logarithm of both sides, and it does not matter which log you take, I use natural log. Reason why? It's easier for me to write. I got Sally and the camel has one big hump and two little humps. So I have ln. Rather than having to take log and have to take my pencil off the paper two times. Okay? ln, I got Sally and the camel, one big hump and two little humps. It does not matter. If two things are equal, their natural logs or their logarithms will be equal. Well, how does that benefit us? Well, that puts us down a logarithm on the left-hand side. The logarithm of 3 to the x. It allows us to take that variable of x out of the exponent. Because, Cole, where can we put that x now? ln. We can put it in front of the ln. So this is going to be x times the ln of 3 is equal to the ln of 30. Now solving for x, Emily, what do you have to do to both sides? I have x times the ln of 3 is equal to ln of 30. What can we do to solve for x? I have a variable times a number is equal to a number. I want to solve for x. If I had 2x is equal to 10, how would you solve that? So I have x times the ln of 3 is equal to ln of 30. What can we do? Not 3. Not just 3. No. ln of 3. So we can take the ln of 30 and divide by the ln of 3. Take it to 3 decimal places. This is not the same as the ln of 10. I cannot combine the 3 and the 30 together or cancel 3 and 30. I have to take the ln of 30 and divide by the ln of 3. Kia, what's x equal?
The log of, or the ln of 27.
The ln of 30 divided by the ln of 3. Type it into your calculator.
.0 or 3.1.
Take it 3 decimal places.
3.095.
3.095. So if I would take, now in your calculator, what I want you to do is I want you to hit your 3 button, I want to hit your caret button, and then I want you to type in 3.095. I want you to take 3 to the 3.095 exponent. Do you get something close to 30? Not going to be exact, but if you would use your answer to take it, take your ln of 30 divided by ln of 3 and have that answer, and then they take 3 to that answer, it'll take you back to 30. Once again, this allows us to be able to solve equations that have the variable and the exponents. And when dealing with this idea here, okay, I have the ln's of 2 things being divided. Do not confuse that with this over here. This is the logarithm of 2 values being divided. This is not 2 separate logarithms. This does not equal the log of a divided by the log of x. It does not equal that. I can't give them their own separate logs here. I can give them their own separate logs by doing subtraction. So when solving these problems on the back side, I don't have to deal with one of those properties. I can just click it so I can do the calculator. Once again, it allows us to be able to solve exponential equations. One of the more important properties of logarithms is being able to pull that variable out of the exponent. And just to reassure some ideas that we have talked about here, we have log base 10, which is a common log. So if I take the log base 10 to 10 to the 5th power, in my calculator, log base 10, so it's a log of 10 to the 5th power. What should happen to these things, since I have both bases that are equal, I should get a value of 5. Or we can move the exponent out front, 5 log base 10 of 10. When these 2 things are equal, this gives me a value of 1, which gives me a value of 5. If I take ln of e to the 8th power, the ln of e to the 8th power, well, in your calculator, you look at the ln button, the second function is e to the exponent. So if I take the ln of e to the exponent to the 8th power, once again, log, when I'm dealing with a logarithm, or a natural log, when I'm dealing with a natural log, that's our log base e. When the bases are equal, they will cancel each other out, or I could take the 8 out front and have the log base e of e, which is a value of 1. If I would take 10 to the exponent of log of 5, ten to the exponent of the log of 5. Once again, I have a base of 10 and I have a log base of 10. They should cancel each other out. Do we come back to the value of 5? If I have natural log, this is log base e of 8. If I take e to the ln of 8, they should cancel each other out. to give us back to 8. So in general, if I have log base b, or b to the log base b of x, they should cancel each other out to be x. They undo each other. Or log base b of b to the x, this should give us back to a value of x. Let's take a look at an equation here. We have log base 2 of x minus 1 plus the log base 2 of x is equal to the value of 1. I want to solve that equation. Well, before, what we had for today is we just had one log on the left-hand side, and we were able to solve the equation. Now we got 2 logarithms sitting there. So what we need to be able to do is we need to be able to combine these 2 logs into one logarithm. Well, I have 2 logs that are being added together. To combine them back into one logarithm, what do we have to do with our 2 values that we're taking the logs of? Multiply them. So we have x times x minus 1 is equal to value 1. Now we have just one logarithm. Let's take it out of the exponential or logarithmic form and move it into the exponential form. So I have a base of 2. I have a value of x, x minus 1. I have equal to a value 1 whenever I solve a problem that deals with logarithms. And I'm setting a log equal to a value. That value is the exponent. Once again, we have to be able to convert from logarithmic form into exponential form. So we have base and we have exponent. This is base. This is exponent. This is our value. So we can go 2 to the first. Here's my base. Here's my exponent is equal to x times x minus 1. So we have 2 is equal to x squared minus x. We can subtract our 2 over. So we have x squared minus x minus 2 is equal to 0. We could factor. And solve for x. Should get 2 negative 1. 2 negative 1. Now, once again, you need to check your solutions. Need to check your solutions. If I put negative 1 back in for x, I get negative 1 minus 1, and I get log of negative 1. As we talked about yesterday, all your logarithms, you cannot take the logs of a negative number. So we have to cancel that one out. If I put the value 2 in there, I get the log of 1 plus the log of 2. I can get a value then. Once again, using properties to solve logarithmic equations. Here you got a worksheet. It goes through all the properties that we just talked about today. There's a lot. I understand there's a lot there, but you need to keep up with us. You need to get an effort going this weekend. Monday will be the same type of worksheet that we have here. Going through the properties of logarithms. Tuesday will be review day. Wednesday, once again, will be the chapter test over logarithms. Questions? QED as done.